Welcome to another video on investment analysis. Now I would like to talk to you about the concept of utility of wealth. Utility of wealth, satisfaction that one gets from having differing amounts of wealth, okay? And what we want to talk about under this general heading are the three types of investors. Three types of investors, okay? One ends up being the category where almost all investors fall in, but we'll talk about the three types. First is risk-neutral investors. The second is risk-seeking investors. And the third, and by far the most common type, are risk-averse investors. Okay? Three types of investors. And again, we're going to see that almost everyone is in this category of risk-averse investors. However, people exhibit different degrees of risk aversion. Okay? Well, let's start off by seeing what a risk-neutral investor would think about the amount of satisfaction or happiness he or she would get from varying quantities of wealth. So we're going to look at a two-space here in red. Now on the horizontal axis, we have wealth measured in dollars, and on the vertical axis, we have something called utility of wealth, measured in some fictional unit known as utils. And the idea is we're trying to quantify happiness or satisfaction. Now, of course, there are many different sources of satisfaction or happiness or utility. We're just focusing on the utility of wealth in this example. Okay, and we want to see how utility of wealth changes as the amount of wealth changes. Okay, and so we'll start off using green, and I'll draw a straight line. Okay, and I'll say that is the utility of wealth function for a risk-neutral investor. And what this means is that if the wealth of a risk-neutral investor increases by, say, $100 from there to there, there's a certain amount of, a certain increase in happiness that comes, and that's measured by that vertical line there, okay? And the point here is that if we have another increase of the same amount of money here, that the increase in utility of wealth associated with that would be the same, okay? So what we have here is this vertical distance here is the same as this vertical distance over here. And so, you know, a $100 increase of wealth from there to there provides a certain increase in utility, and a $100 increase in wealth from there to there provides the same increase in utility. So for a risk-neutral investor, the utility of wealth function is linear with some positive slope. And that straight line, of course, has a slope that doesn't change. The slope doesn't change no matter what happens to wealth. The slope of the risk-neutral investor's utility of wealth function remains the same. Now let's look at this relationship now. Utility of wealth on the vertical axis and wealth on the horizontal axis. Let's look at this now for a risk-seeking investor. And we're going to see in this case, and I'll do this one in purple, for a risk-seeking investor, this relationship looks like that. Okay, so that's a risk-seeking investor's utility of wealth function. And what we see here is that given some increase in wealth, that the increase in utility here is less than the increase in utility associated with the same change in wealth out here. Right? So it's this distance, this vertical distance versus that vertical distance. And we see that risk-seeking investors seem to get a bigger kick out of getting the same increase in wealth when they have more wealth. Interesting, okay? And so this line here has a positive slope, and we see that the slope of this line is increasing as wealth increases. Okay, we'll come back to that in a moment. Now let's look at a third two-space. Let's look at, the same utility of wealth. It's the same two-space, the third circumstance. Utility of wealth is a function of wealth. And this is going to be for a risk-averse investor. And I'll put this one in blue. Okay? And this line will look like that. So this is the utility of wealth function for a risk-averse investor. And this is by far the most common case, by far. Okay? And here we see that given a certain increase in wealth, that the change in utility of wealth down here is greater than the change in the utility of wealth, the same increase in wealth up there. Put the points here like this, and then try to get the same size change here. And you can see that, try to put this in pink for you, that this vertical distance here is bigger than that vertical distance there. And so for risk-averse investors, a given amount of increase in wealth provides a greater increase in utility of wealth at low levels than in higher levels. Okay, so that's how that works. And we see that this utility of wealth function for the risk-averse investor has a positive slope, and the slope is decreasing as wealth increases. So again, as wealth increases, the slope of this line decreases for the risk-averse investor. Again, almost everyone is risk-averse. However, people exhibit differing degrees of risk aversion, and we'll have a lot to say about that as we go on. So these are our three circumstances for risk-neutral, risk-seeking, and risk-averse investors, and how utility of wealth behaves as wealth changes. Okay, and now we can quantify what's going on here and try to specify if we wanted to model the utility wealth function mathematically. We could look at risk-neutral investors, we could look at risk-seeking investors, and risk-averse investors. And we could look at what I'll call U prime, the first derivative of the utility wealth function. I'm going to put that up a little higher. Okay, so call it U prime. And then we'll look at the second derivative of the utility wealth function, U double prime. And we see that for all three of them, here, here, and here, that the first derivative for all three is positive. So we just put the sign of that derivative U prime. Okay, U prime is just the change in utility associated with the change in wealth. Okay, change in utility associated with the change in wealth. And now here we have the second derivative. Okay, let's look at it. Well, we see for the risk-neutral investor that's a straight line. Well, that means that the slope isn't changing, so the second derivative is zero. Remember, the second derivative, U double prime, is just the change in something associated with the change in wealth, and the something is the first derivative, du dw. Okay, so this is what U double prime is. Okay, the second derivative of utility of wealth with respect to wealth. Now, for a risk-seeking investor, we see that the slope of the line increases as wealth increases, so that means the second derivative is positive. Okay, and then when we look at the utility of wealth function for a risk-averse investor, we see that as wealth increases, the slope of the utility wealth function, it's always positive, but it's decreasing. It's less positive as wealth increases. So the second derivative for the utility wealth functions for risk-averse investors is negative. Okay. Now, if we wanted to mathematically specify these functions, we could, for a risk-neutral investor, we would just use a linear function to specify the nature of the utility of wealth function for a risk-neutral investor, linear. So, something like utility equals 5 times W or something like that, okay? And then we see, by the way, that du dW in this case would equal 5, and that's positive, right? And then we see that du dW, which is u double prime, is, what's 5 is a constant, so it doesn't change, so its second derivative is 0. So we could use linear specifications for the utility wealth function for a risk-neutral investor. For a risk-seeking investor, what type of functions could we use to specify their utility wealth functions? Well, we need something with a positive first derivative and a positive second derivative. So what we could use here are power functions. And we could also use exponential functions. Okay, so an example of a power function would be u equals w squared. And then just to check to make sure we get what we need here, positive first derivative, positive second derivative, we see that du dw would equal 2w, and we see that that's positive, okay? And then we look at the du dw. Again, this is just a change in the slope associated with a given change in wealth. And that, of course, is 2, and that is positive. So power functions work. Let's look at exponential functions. It would be something like this. U equals 2 to the w power, for example. With exponential functions, the variable appears as an exponent. And the first derivative du dw here would be, if you recall, in order to calculate these, you differentiate the exponent with respect to w in this case, and this is 1w to the first power, so the derivative of that with respect to w just ends up being 1, so we have 1 times 2 to the w power, and then we have to multiply that by the natural log of the base, which is 2, okay? And this is positive, okay? And then we look at the second derivative, du dw dw, and that will then be the same thing again. I'll do it this way. We'll put the base down, 2 to the w, which is right there, and the 1 just kind of is there when we're multiplying. And so we kind of started with 2 to the w. Oops. Oh boy, excuse me. I have no idea what I just did. There we go. 2 to the w, and then we differentiate this with respect to w, and we get 1. And we already had this. The natural log of 2 was there. Okay. And then we have to then take the natural log of the base again. Okay, so there's what we're left with for the second derivative of utility with respect to wealth. And that, too, is positive. So, hey, that works, too. So both power functions and exponential functions can be used to specify utility of wealth functions for risk-seeking investors. Okay, that's good. Now let's look at our third type of investor, and that is risk-averse investors. Okay, that's this case here that we saw. And let's work through, the mathematical specifications for the utility wealth function for these folks. And so here we have for risk-averse investors, we need a positive first derivative and a negative second derivative. So what would work? Now, what type of functions would give us this? Well, the first type that comes to mind are root functions. For example, u equals w to the 0.5 power, which is the same as the square root of w. Okay, that's a root function. Let's see how that works. du dw then would be equal to 0.5 w to the minus 0.5. That's the same as 0.5 divided by w to the 0.5 power, right? And important point is that this is positive, all right? That is positive. Don't let this minus sign here confuse you. That's just w to the minus 0.5 power is just 1 over w to the 0.5. And so this is positive, okay? Now let's look at du dw dw u double prime, okay? And it's kind of easy to use this because now we see what happens. So we have the minus 0.5 comes down, so we have minus 0.5 times the 0.5 times w. Now we have to subtract 1, so we get minus w to the power minus 1.5. And please note that this minus sign doesn't make this term negative. However, that does. So important to realize that this indeed is negative. Okay? So we see root functions can be used to specify utility wealth functions for risk-averse investors because, as I just showed you, we get a positive first derivative and a negative second derivative. Now, another type of function you can use for risk-averse investors and trying to mathematically specify their utility wealth functions are logarithmic functions. You can say u equals the natural log of wealth. Okay? And so du dw in this case would be 1 over w. Okay? In this case, it's the derivative of what's in the parenthesis divided by what's inside the parentheses. Okay, so there's the derivative of w with respect to w is 1, and then the function itself is w. So that, and this is written as w to the minus 1. I show you this because then you'll easily see why we get the necessary result when we take the second derivative. So du dw, again, the change in du dw, the change in the slope associated with the change in wealth, is equal to minus 1 times w to the minus 2 power. And now, once again, I'll remind you that it's not this minus sign that makes this term negative, but rather that one. So this is indeed, this is indeed negative. Okay, so negative. Excuse me. So again, the first derivative was positive, second derivative was negative, and we see that logarithmic functions will work when we try to use them or when we wish to use them to specify mathematically a utility of wealth function for a risk-averse investor. And that's all I have for now. Thanks for watching.